Okay, so what we're going to be doing for this one is looking at recursion relationships. And what I've actually got here is the study design. And I've put this here really to highlight where it fits in with what we're doing. As you can see, it uses first order linear recursion recurrence relationships. Okay. Again, here we see first order linear recursion, use a recursion relation to model and compare. And what you're going to notice here is it's in relation to the financial mass. So in terms of flat rate, unit cost, and reducing balance depreciation, we're using these recursion relationships. So here's another example when we do compound interest. We can have another recursion relationships to model analyze. Okay, so what we're actually doing again, here's another one. So the purpose of what I'm going to go through in a moment is to talk about this. It's really to look at how we generate the terms for a first order recurrence relationship, using this to solve related problems, work with first order recurrence relations with a common difference and ratio, graph these relationships, and interpretation of the graph of a first order recurrence relations. Now, am I going to do that all in one video? No, I'm going to break this up into about 3 different videos. So our first one we're going to look at it is generating the terms of a first order recurrence relation. But as I noticed as I pointed out in the study design, but just to re-emphasize here, we're doing that to model financial situations. Okay, such an example there given, such as the amount of interest accrued in a bank account over a number of consecutive years. The key point here, consecutive years. Okay, now what are we talking about? What a recursion relation is? It links, that's the consecutive part, it links one term in a series to the previous or the next term in the same series. That's the consecutive part we're talking about. So going from like year 1 to year 2 to year 3 to year 4. That's each of those is consecutive years. Okay. Now, here's what we've got. Generating the terms of a first order recurrence relation. So what it's talking about, it relates a term in a sequence to the previous term in the same sequence. All right. So what we need to start with is an initial value. And from that, we can generate what we need to generate after that. And what we call here, we've got here, it says the nth term, okay, is represented, we've got here by UN, and the next term is represented by UN plus 1, or the previous one being UN minus 1. UN being like if our fifth value is going to be U5, our next one would be UN, so 5 plus 1, so 6. The previous one is N minus 1, 4. Okay. Now, here's what we're, when we write them, we can have a sequence that looks like this. The sequence can be 1, 5, 9, etc. You've got the numbers there. So what we're saying here is our sequence is UN plus 1 equals UN plus 4. See, UN being my previous term and my N plus 1 being my next term. Okay. And now I'm stating that the first number I'm going to look at is 1, and you always got to include something like this in there. You've got to state what that first term is. We'll get that in a moment. Now, what we've got here is, for example, if I put 1 in there, if I put where UN, I put 1, 1 plus 4 equals 5. Okay, that equals 5. So that's my N plus 1. So that's where, let's get a marker, that was here, and the 5 is this one. Now, when I do it the next time, my 5 becomes my UN, so I get 5 plus 4. That equals 9. I put 9 here. 9 plus 4 equals 13. See what's happening? Then I'll go 13 plus 4 equals 17. Okay, And so here's a nice, nice little, I don't know what you would want to call it, thing to, to actually have. It's probably worthwhile that somebody have like something like this in your summary book, just because it states it, and you can sort of have that statement there for you. Whether you want to copy it or just write it out, it's up to you. But here's what we're talking about. When we've got two successive terms, we're saying the previous term, the next term. Now, it can also be written slightly differently. And this is where it could be a little bit confusing for you, where I've got some, but where UN is now my next term because I'm stating that the previous term is UN minus 1. Now, I can understand why that can get a bit confusing just because you sort of get used to one way and it does it a bit differently. Okay, but the point being that there's a previous term. It's either, let's see if I can, this will highlight previous term and a previous term and next term and the next term. You notice that, sorry, I should actually, that's what you've got to keep in mind. Notice, notice the like this one here and this one here. That helps you work out whether UN's previous or next. Okay. So I mentioned earlier something about starting term. And I just wanted to sort of make a note here. You can have, for example, the starting term determines what numbers you see over here. Because if the example here given here is that this recurrence, this part of the relationship is the same. But if my starting number is different, I get different numbers because it becomes 3 plus 2 gives me 5. 5 plus 2 gives me 7. Whereas if I started with the 2, I get 2 plus 2 equals 4. 4 plus 2 equals 6. Okay? So that's a general idea you've got to work with here. Now, let's have a look at this. The following equations each define a sequence. Which of them are first order recurrence relations? So I need something that defines a relationship between two consecutive terms. Okay? And we can see in this one here, A, so I'm going to put A, I'm going to say it is, I'm just going to write it is first order. And the reason, I've got the UN and the UN minus 1. The UN minus 1 being previous. Remember, if we go back to this term here, this is previous term, and this is my next term. Okay? All right. So I'm going to say yes, and plus it's got this the starting term because I need that starting term there. Okay. For B, let's have a look at B. B, it says UN equals 4 plus 2n. Okay. That's not B. Not first order. And why isn't it not first order? Well, there's no relationship between two consecutive terms. Remember, it's a key point. The consecutive being, has to be one after the other. And C, it says fn plus 1 equals 3fn. So you've got your two consecutive terms. You've got your fn n plus 1 and the fn there. So the fn here would be your previous, and this would be your next. But the problem is there's no starting term. So it's an incomplete first order. Okay. Recurrence. And the reason it's incomplete is that there's no starting term, so I can't actually start a sequence. Okay. Now, I'm going to go to worked example 2. Oh, that wasn't supposed to come up. So worked example 2, all right, this is where we've got a starting term. And what we've got to look at here, all right, I don't know if I left myself enough space here. My term is, let's actually write it. I'm going to write UN equals 3 UN minus 1 plus 5. Remember, this is previous, this is next term. Okay, and my U0, so that first term I could write it as U0 or U1. It can, whatever you can pick one or something like that. That you know, you get that choice, or you'll be given that choice. Okay, but here I'm starting as U0. So what that becomes is, if I go U1, because U1 in this case will be my next term. So my previous term is U0, okay, plus 5. Now I've been told that U0 equals 2. That's up here. So that means 3 times 2 plus 5 equals 11. Okay, then I go U2 equals 3U1 plus 5. So that means 3 times 11 plus 5 equals 33. I'm going to change color. I'm going to go U3 equals, so it's going to be 3U2, remember consecutive, plus 5, so 3U2, what was U2? U2 was 33, so that becomes 99. Well, that should have been 38, so clearly I can't count. Okay. I'm sure somebody's going to laugh at me for that one. And clearly that answer's wrong too. So is that. So when I do 3 times 38, so if I go 3 times 38 plus 5, 3 times 38 plus 5 is going to give me 119. If I add in U4, we equal 3U3. Okay, that's a U plus 5. That's going to give me 362. So if I go 3 times 119 plus 5, I'm going to get 362. Okay. And you'll notice, I'm going to make some links here for you. U1 there. U2 there. U3 U's there. Now, what are the first 5 terms? Well, our first 5 terms, because we're going to count U1 as the U0 as our first term we use, so it's going to be 2, 11, 38, 119, and 362. Okay, so that's what you'd have to write in a question like that. So let's go to the third example here. This one's sort of asking you to do something a little bit different. So we've got a sequence defined by the first order recurrence relation. Here's my relation here. Remember, guess what this is called? This is called the previous term, and this is the next term. Get used to remembering that. Well, in here, n is 1, 2, 3. So if the fourth term of the sequence is minus 29, so that means U4 is minus 29, then what is the second term? Well, you're going to have to do a couple steps here. Okay? The steps that you would need to do is is to calculate U3 and then U2. And now you're going, how the hell do I do that? Okay, the way you're going to do that is to put the number in. So if I write out my just give us a moment. Okay, so sorry about that. I'm just going to rub these out for a moment because I want to be able to write this equation properly. Okay, so what I'm going to write out the equation here. UN plus 1 equals 2 UN minus 3. Now, in this case, we actually want this one. Okay, so we have to rearrange the equation. We have to transpose such that I get it in terms of UN. So how do I do that? I'm going to move the minus 3 across, and then I have to divide it by 2. So what I end up with is UN equals UN plus 1. Remember, that's our next term, and that's going to be our U4. Let me write it like this, plus 3 divided by 2. So effectively what you've got here is U3 is U4 plus 3 divided by 2. Well, we're told what U4 was. U4 is minus 29. So minus 29 plus 3 divided by 2. That's minus 29 plus 3 is minus 26 over 2 is 13. And I want the second term, so I'm going to have to do, it's going to be the same, equation is written the same way. U2 equals U3 plus 3 over 2. Oops, over 2. U3, oops, that's a negative 13, was negative 13, so that becomes negative 13 plus 3 over 2. Negative 13 plus 3 is negative 10 divided by 2. The answer is negative 5. Okay, so the second term U2 is negative 5. Okay, and that's how you would start to do these problems. Okay, sorry, this was a bit of a longer video than I was expecting. Okay, bye.